Continuing in section 2.1, going on to sketching graphs and basic equations. So there are several methods for graphing equations. We can go back to the most basic, point plotting, or plotting some points, setting up a table of x and y values, plotting the points, and then connecting the dots. So if you're ever looking at a graph of something that you don't know, like maybe you don't know for sure what a cubic looks like in this graph, let's go ahead and use some point plotting here. Okay, so if I just set up an XYT chart and we just plug in some numbers, so if you plug in 0 for x real quick, you'd get -3 for y. If we plug in 1, calculate 1 minus 3 would be -2. Plug in 2 cubed, 8 minus 3 would be 5, and then we should plug in some negative numbers. So -1 would give us -1 minus 3, so -4, and maybe -2 would give us -8 minus 3, so -11. Okay, so just so you know, we do want to say about labeling and stuff, so we'll do that in a minute. Let's go ahead and plot those points. But just so you know, up here, guys, it just has to do with the pixels and the way the projection works from the projector. So some of these are not going to look as accurate as they actually would on your graph paper, because each of these that kind of looks like rectangles on the graph paper should look like squares. So that's just something you have to get used to when we are using this method for showing you graphing. Okay, so here, anyway, 0, -3, 1, -2, 2, 5, -1, -4, and -2, -11, which I know mine's 10 by 10, so -11 would be down here. Okay, so each of these, while I'm graphing with you today, I'll probably turn the video off just to make it a little bit shorter. But go ahead, what you're trying to do is make this a nice smooth curve. It's easiest to go from this middle dot here, okay, just from what I know about cubics, and it curves in this direction. Okay, and then to go from the middle and have it curve in this direction for this part. Okay, again, nice smooth curve, no sharp corners. And then we are going to say that we need to label these points. Okay, so on a homework or a quiz, it's easier to just label the ordered pairs that we're going to grade from you instead of labeling the x and the y axis completely. So I would always graph it first so that you don't write over these points, and then label your points. Okay. All right, so let's make a note here to label all required points, which we'll talk about how many are required for each kind of graph. So label all required points on homework and quizzes. Okay, and that's what we're talking about from what we just did there. And I would say also use ordered pairs to make it faster than labeling the axes. Again, use ordered pairs to make it faster than labeling the axes. Okay, of course this graph goes on forever, hence the arrows at the end. Okay, it's just part of those details to watch. All right, so there's point plotting. Next, other methods of graphing include having knowledge of what the type of equation is that you're graphing, right? So look at number 2. What method would you use to graph the linear equation, right? I hope we're all thinking y equals mx plus b. We're going to read our y-intercept off of it being 0, -6, if you will. Okay, 0, -6, and then a slope of 3 over 1. So rise over 1, up 3 over 1, up 3 over 1, and so on and so forth. So of course, for most of these graphs, guys, if it's a line or it's an absolute value, something that can cross the x and the y axis somewhere, extend it. Okay, definitely extend it so that it can cross through the x and the y axis. Do your best to make your best straight line. You guys all have an ID or a straight edge of some sort, okay, that you can use to extend that, and we would be set there. All right, so let's get to some basic equations. Okay, so equations that you're going to have memorized, and then you, of course, you will use the translations and stuff that we've done in the previous stuff. Okay, so basic equations. The equation of a circle, x minus h quantity squared plus y minus k quantity squared equals the radius squared. Okay, where the center is hk, the radius is r, and for us, for my class, 5 points are going to be required for graphs of circles. Okay, so anytime you know it's a circle, you must have 5 points. Okay, all right, so for me, here's how you're going to see me do, since you have all of the answers right in your workbook on the graphs. I'm not going to just draw the graph for you. I'm going to try to show you like where my work is coming from. So for me, when you see my work, the first thing I'm going to do is write down my center, my HK, if you will. And if you're reading it off here correctly, it would be 2, -4. My radius would be, well, remember this is r squared, so my radius would be 5. And so I'm just going to make a picture that sort of looks like the points that I'm expecting. Okay, so here you go. Leave yourself a little room. You'll see what I'm doing in a minute. So I'm going to say my center is 2, -4. And the 5 points that are going to be required are that center one, and then one above and below it, and one to the left and to the right of it. Okay, so if my radius is 5, and I want to know the point that would be above it, it would be changing the y values. So if you go up 5, you should be at 2, 1. If I go down 5, I would be at 2, -9. Now that you know what I'm doing, you can try to fill in the others. The one to the right, if I move to the right 5, I would be at 7, -4, because that changes the x values now. And to the left, I would be at -3, -4. So that's what my work is going to look like on my paper when you check it. Okay, go ahead and plot those points real quick and come back and check. So again, those pixels are going to make this look a little bit odd. Draw the best circle that you can. Okay, you can see the 5 points. What I want you to do for me, of course, you're going to finish labeling this. I'm going to skip that just to save time. But you're going to label those 5 points that are required. But for me, please make sure that you also make these 5 points very, very large once you draw through them. Okay, so that they are very easy to identify. Okay, so that would get you full credit as soon as you have that labeled. All right, next for a parabola. Parabola is what we call U-shape. We've been talking about that quite a bit. So if we're talking about y equals a quantity x minus h quantity squared plus k, then we're talking about a vertex being hk, and the a, the number in front, has to do with the direction of the parabola and the width of the graph. So if we're doing a y equals, then when a is positive, the parabola opens up. When a is negative, the parabola opens down. For me, 7 points are going to be required for graphs of parabolas. Okay, so 7 points are going to be required. Now, to make plotting a parabola a little bit faster, we want to talk about this 1-3-5 rule that you may have talked about in Algebra 1, and you'll definitely hear through the rest of your classes. So let's talk about just the pattern of the basic parent graph of just y equals x squared. Okay, and let's just plot some points. So if you plug in 0 for x, you get 0 for y. If we plug in 1 for x, we get 1 for y. Plug in 2, we get 4, right? And plug in 3, we get 9. Okay, and of course, if you think about it on the other side, if you plug in -1, you're going to get the same y value as +1. When you plug in -2, you still get the 4. When you plug in -3, you still get the 9. Okay, so I kind of like to do just the right side of a parabola and then just kind of mirror it on the other side. But here's the point of what we want to look at. Yes, if I was going to just draw the parabola y equals x squared that I drew there, do try to make this U-shaped, right? So no sharp corner. So from the bottom, I like to usually just try to do the right side. You know, a parabola goes on forever, so you do need that arrow. And again, on the left side. Okay, so do the best you can to make it a nice smooth curve. The 7 points that we are talking about are definitely these 7. So after you've drawn it, make those nice, big, easy to see, okay, and get them labeled. But let's talk about that 1-3-5 rule that we're talking about. And let's notice some patterns. So this 1-3-5 rule says that from this vertex of 0, 0, if I move over 1, notice I go up 1 from point to point. And if I now move over 1 again, I go up how many? 3. If I move over 1 again, I go up 5. So what do you think would be next? If I move over 1, I should be going, if I'm following a pattern, up 7. That's the 1-3-5 rule, okay? 1, 3, 5, 7. And think about it, it's really just about how x squared works, right? If you went over to x being 4, 4 squared would be 16. Okay, so 16 from this y value of 9, right, would be 7, 7 up, okay, from that point. All right, so there's your 1-3-5 rule that we're talking about, which means now, let's say that somebody gives you y equals 2x squared. All right, well, it's still going to follow the 1-3-5 rule, right? It's still every time you take a step to the right, 1. But now the y value, think about this, the y value here, once you multiply x squared, right, x by itself, the y value is getting multiplied by 2. So now this is going to move over 1 from here. It's going to move over 1 and up 1 times 2, if you will. So it would go up 2. The next point would go over 1 and up 3 times 2, so up 6. And the next one would move over 1 and up 5, but times 2 for that constant, so up 10. Okay, so that's what we call the 1-3-5 rule, and we just use that pattern that we know from the basic y equals x squared to plot those points. All right. All right, next, a cubic. A cubic is what we call S-shaped. That's like the first problem that we did when we were plotting the points. Okay, but now let's go ahead and memorize what we know about this. So y equals a x minus h quantity cubed plus k. When we say S-shaped, we're talking about this. Okay, so notice nice smooth curve. I usually draw it from the middle and go up, and then the middle and go down. All right, your center point, if you will, that center point that I've just highlighted right there, that's the HK. Okay, A has to do with the direction and the width of the graph, like how vertically close it is to its center point. Again, for me, 5 points are going to be required for this graph. Okay, so let's talk about the difference between y equals x cubed. And of course, you could go through and just plot some points, but I want to go through like the difference between y equals x cubed and y equals 2x cubed. So why don't you plot points for y equals x cubed and also y equals 2x cubed, and come back and join me and we'll look at the differences. All right, let's see how you did. So for the first one, y equals x cubed, you've got 0, 0, 1, 1, and 2, 8. Again, go from that center point, guys, I think is the easiest so that you can look at this curvature, if you will. Okay, go from the center point down, try to make it curve this direction. Again, goes on forever. All right, versus the y equals 2x cubed. I'll change colors, still goes through 0, 0, but 1 goes up to 2, and 2 goes up to Well, 2 cubed, 8 times 2, 16. All right, so if it happens to be off our graphs that we give you, okay, so I know that's not accurate, that's not up high enough, but you know what, guys? All I want you to do is label it, okay? So when I see that final point up here that's off the graph, I just want you to label it for me 2, 16, so I know where it was headed. Okay, so I'm not saying actually extend your graph out that far. Just put a point out there, tell me where it's headed. Okay, same thing down here, right? This one is definitely off the graph, but I'm mostly trying to draw both of these for you so that you see what we mean by, if you go from the center and you go here, you notice that it's going to get, and that's more headed towards where that point actually would be. It's just going to look maybe a little bit skinnier is maybe how you would define it for yourself. Okay, and do the same thing you can here. And again, arrow codes that's going on forever. Okay, so there's your difference there. So again, just label all 5 points and you would have your full credit. All right, a square root is what we call arc-shaped. Okay, arc-shaped. And by that I just mean this. Okay, it starts someplace and goes off in one direction. Okay, if you will. So your starting point, your HK, is this point, okay, that we're talking about. So that would be my starting point, where you go off in one direction. All right, so there's a few different things going on here. We do want you to have 2 equations memorized for a square root. And it really has to do about the number that's in front of the x, whether it's positive or whether it's factored out as being a negative. So let's talk about this first, okay, the a. So again, if a is positive, then it opens up. Okay, if a is negative, it opens down. Okay. This part then, this part being a positive in front of the x, tells you that the function opens to the right. All right, so let's make some pictures of what that would mean next to this. So if I am opening, let's say, up and to the right, I would have maybe a starting point and look like that. If I'm opening down and to the right, I would have a starting point and look like this. Okay, let's go for the next one. So once again, this a part, nothing changes. If a is positive, then it opens up. And if a is a negative, it opens down. And then you probably already guessed it. That negative is going to mean this time that it opens to the left. So again, putting 2 pictures with this. If I am opening up and to the left, I would have like a starting point and then open up and left. And if I am opening down and left, here's a starting point to go down and left. Okay, so really there's 4 different kinds of things there. Again, I'm going to say for this one, 4 or 5 points required for the graph. And again, like that last one we were talking about, if it's a ridiculous number off the graph, no, I don't want you to extend your graph paper or anything. I just want you to maybe tell me what that 4th or 5th point would be. So if you can, it's not a ridiculous number, go for it. And you'll get to practice in the homework what we expect for that. So let's just do our general y equals root x. Now, please understand the 1-3-5 rule is really for parabolas. I just kind of apply it here because a parabola and a square root should be somewhat related to you, right? It's squared versus to the 1/2. So to me, in my mind, yes, you could plot points, right? 0, 0. Think about the points that you could plug in that would be nice. If you plug in 1 for x, the square root of 1 is 1. The next nicest number to plug in for x would be, what, 4? Square root of 4 would be 2. And if you plug in 9, then the square root of 9 would be 3. Okay. The next easiest one to plug in would be what? 16. Square root of 16 would be 4. So again, you could have that one off the graph and just have it labeled. Okay. okay, if you will. So anyway, here you go. Nice smooth curve. Again, if it was more accurate as far as going clear out, that point would be out there. Again, you would just label it, put a point out there somewhere, and label it 16.4. Okay, so you would plot your four or five points. Again, once you've filled them in, make them nice and big, easy to see, label them, and you're set. Now, just kind of the reverse of the 1-3-5 rule. Think about this, if it would make sense. This now would say for every one you go up, you go over 1. For every one you go up, now you go over 3. For every one you go up, you now go over 5. And the next one would be up 1 and over 7 again. Okay, like it was for the last time. So see if that helps you. Again, goes on forever, so it should have an arrow. Absolute value that we've been working with, V shape, right? So this is the one that will have a sharp corner. Okay, so your definite, there's your equation that we want to have in general. Y equals A, absolute value of x minus h plus k. The vertex or the sharp point, again, would be at the hk. A works the same for absolute values as it does for parabolas, okay, as far as what it does for the graph. 5 points are going to be required for the graph for me. Okay, and remember, if we have said like y equals, let's just practice with one. If we were going to plot like y equals the absolute value of x minus 3. Okay, remember you could take what's inside the absolute value, x minus 3, set it equal to 0. You know that's where the vertex is going to be. You could also just plot a point, right? If you put in 3 for x, 3 minus 3, it's going to give you 0. Absolute value of 0 is 0. So there's where your v is going to be. We know from what we've done with our piecewise functions, the slope, right? If you kind of just think of that as your piecewise function, y equals mx plus b, the slope is 1 and negative 1. So a slope of 1 would be up 1 over 1, over and over, and the slope of negative 1 connecting to that vertex point would be this. And then just like we said with the line, please make these absolute values and lines at least extend. Like, don't draw just an itty-bitty little graph, okay, like a V, but make it actually extend through the x and the y axis. Try to show me where it intersects those, okay, if you will. Goes on forever. So there's your arrows. Again, if there's something I'm needing to see, you can just make your points larger after you connect them. Okay. There we go. So we'll make the note to please extend to go through x and y axis. X and y axes. All right, so there's really the end of the notes, but let's practice going through problem 1 on worksheet 2-3 together. Let's at least start that. Okay, so if you want to grab worksheet 2-3, this is the problem, or maybe you just do it here in your notes and then you go back and redo it to make sure that you understand it yourself. Okay, so first things first, you should be identifying it first. You should recognize that as a parabola, right, because of it being squared. So you should pull your vertex point off of it, which is your HK, and your HK, if you get that memorized correctly, will be 3, -4. The next thing I always look at is my A value, and I decide if this opens up or down. So notice this A value, which sits in front, is a +1, and therefore that tells me that this opens up. Okay, so again, you're going to be plotting these, but I'm trying to give you the work so that you kind of think about where I'm coming from there instead of just showing up with a graph. So I plan ahead. I say, all right, I'm going to start at the bottom, leave myself a little bit of room. I know I'm required to have 7 points, so I'm going to start at the vertex point, and I'm just going to say to myself, okay, this point is 3, -4. And I know from my 1-3-5 rule that I am going to go out 1 and up 1. Okay, and so I will label that next point, which would be 4. If you go out 1 and up 1, I'd be at 4, -3. Okay, again with the pattern, if I go out 1 and now up 3, I'd be at my new point. And that next point would be, well, if I move to the right 1 and up 3, I would now be at 5, 0. Right, and I know I need one more point on this side of the parabola, if you will. So if I go out 1 and up 5, I would now be at 6, 5. Okay, so that's all I'm going to show you on my paper, because my thinking is that now from the vertex, I'm just going to mirror this on the other side. Okay, I'm going to mirror that on the other side since it's opening up. So we've got 4 out of 7 of the points. You do the other 3, mirroring it. Okay, so there's the work that you're going to see from me. All right, good luck on this graphing stuff.